And another prediction of the study was that eagles assess the relative fighting ability or expected gain of an opponent and act accordingly. And the results actually supported this prediction, and this means that eagles kind of size each other up. And they look at the other's size, their strength, and their hunger level. And as Hyder already said, the bigger eagles are going to attack smaller ones, the more hungry eagles are going to attack the less hungry eagles. And therefore, the pirates were able to predetermine whether or not their attack would be successful based on both eagles' payoffs. And the fifth prediction stated that ritualized displays advertise an individual's fighting ability, but not its expected gain in victory. And part of this prediction was true. The displays did advertise the individual's fighting ability, but it also advertises expected gain in victory. And this is because whenever an eagle was more hungry, it would give more displays, which means it was more likely to win an attack. So therefore, the signaling strategy is efficient for both eagles and is evolutionarily stable. And the next prediction was that fighting intensity increases as food becomes scarce. And Hansen created a formula that was P equals B over C, where P is the probability of fighting, B is the resource value, and C is the cost of injury. And according to this equation, the eagles would be more likely to fight whenever food resources decrease. And this actually was true. The pirating eagles were more likely to attack, and the feeding eagles were more likely to fight back. So overall, aggression of the bald eagle is inversely proportionate to the abundance of food in the environment. And the final prediction stated that the ESS point is or is not affected by resource abundance, depending on the payoffs of each strategy under different feeding circumstances. In other words, he predicted that if the payoffs of hunters and pirates decrease proportionally as the food sources decrease, then the ESS for frequency of pirates would remain constant regardless of resources. And they actually did find this to be true, and the abundance of pirates decreases as the food resources decrease. And this is a model of the foraging game of the eagles. And you can see that about 50-50 they'll hunt or they'll pirate, and they're usually equally successful in both cases. And most eagles who are feeding do become attacked, so it's kind of like a cycle, and they go back to the top as they become hungry again. And this is just a picture. You can see one of the eagles who's feeding is submitting to a pirating eagle. And in this you can see that the payoff for hunting may be greater as you'll get more food, but the cost is also greater. So they kind of equal each other out, which is another reason it's evolutionarily stable. So overall, the study provided support for several predictions of game theory, and most importantly, it revealed evidence that a hunter-pirate type population can remain evolutionarily stable.
Does anyone have any questions?